So this is a lesson on 10.7 in chapter 10, which is all about circles. 10.7 is specifically talking about the equations of circles and the standard form equation of a circle. When you're taking an SOL in Virginia, this is a formula that will be provided for you on your formula sheet. The important thing to remember is even though the equation's given to you, you still need to understand what these variables represent. So the first thing that I want to caution you on is x and y are variables, but they represent all the ordered pairs or all the points on the circle. So as I travel along the outside of a circle, which are all the points equidistant from the center, these are all points that lie on the circle, all the xy ordered pairs. Now this isn't unfamiliar because back when we talked about lines in y equals mx plus b form, x and y also represented variables, but all the points that lie along that line. So now we're going to go ahead and add into those variables h and k. hk represents the center of the circle. And r represents the radius of the circle. Radius. So we're going to go from a graph to the equation, from characteristics to an equation, from characteristics to a graph, so that you have a good understanding of how these equations relate to the graph and its features. So here we have three examples of circles where all three circles have a center at the origin, 0, 0. So I can see that all three of these have a center at 0, 0. Therefore, h and k are both 0, 0. So when I fill out my equation, x minus h squared plus y minus k squared is going to equal the radius squared. So rather than writing it minus 0, you can see down here in the equations they did not write down plus minus 0 on either of the x or y terms. So if you don't see it something added or subtracted from x and y, then you know that the center is at the origin, 0, 0. Now the big difference between these three equations is the distance from the center to the edge of the circle. All these distances for this picture have a distance of 2, so that means the radius is 2. Here, my distance from the circle to the center, or the radius, is 3. And here I have a circle where the distance from the edge of the circle to the center is 4. Now if I look at the three radii, 2, 3, and 4, and then I look at the equations, 4, 9, and 16, you might recognize that what I'm doing is I'm squaring the radius to find the value in my equation. Because 2 squared is 4, 3 squared is 9, and 4 squared is 16. So that's an important relationship we have to understand between the radius of a circle and the equation of a circle. Let's look at our first example here as a group. Remember, you can always pause the video and attempt the problem on your own, and then follow the video to double check to make sure you did it correctly. So let's look at the very first example. Write the standard equation of a circle. So again, I'm going to need to do x minus h squared plus y minus k squared is equal to the radius squared. That will be given to you. With the center at 0, 6 and the radius at 3.6. So I'm going to highlight some important information here. If they're telling me the center is at 0, 6, that means I'm going to go ahead and label h as 0 and k as 6, because that's the hk value in the center. I also am given the radius, so the r is equal to 3.6. But remember, the radius and the equation are different because I need to square the radius. So in the end, I'm going to go ahead and do 3.6 squared in my equation. X minus the h value, 0, plus y minus the k value, 6. So we're going to simplify this a little bit. We don't need to have a minus 0, so I'm going to have 8x squared plus y minus 6 squared. And when I square 3.6, I get 12.96. So the standard form of this equation with a radius of 3.6 and a center at 0, 6 would be given right there. Example 2, we're going to find the equation, we're given the equation of a circle, and we're asked to graph the circle. So to graph it, I need two things. I need the center, HK, and I need the radius, R. So when I look at this equation, x minus h, what is being subtracted from x? Well, that'd be 3. So the h value is 3. Here, y minus k, and if I have a y plus 1, really what I'm doing is I'm taking away or adding 1. So again, the k value is going to be opposite signs, so this is going to be a negative 1 for k. Because minus and negative is really plus. Finally, I have r squared is 16, so that means r, if it had to be the square root of 16, that would mean r is equal to 4. So the first thing I'm going to do is I'm going to plot the center of my circle at 3, negative 1. So that's the h and the k. So I'm going to go 3 on the x-axis, 1, 2, 3, and I'm going to go 1, negative 1 in the y-axis. There's my center. To draw a circle as best I can, I'm going to go ahead and count the radius up, down, left, and right. Those are easy measurements to find because they're going along the grid lines of my graph. So I'm going to go up 4, 1, 2, 3, 4. I'm going to go right 4, 1, 2, 3, 4. Down 4, 1, 2, 3, 4. Left 4, 1, 2, 3, 4. Then the best I can, I'm going to sketch a circle that's going around and through those points on the edges of my circle. Let's look at our final example here. We're given a point on the circle, a point on the circle, and we're also given a center. The center of the circle is negative 3, 4, so that's my h and k. Hopefully you can remember that. Write the standard form of the equation. So at the end, we want to write an equation that's going to look like this form. So I'm given h and k, so I can go ahead and plug in those values. Minus and negative is really plus. This is going to be a minus 4. So I do know that h and k are going to look like this. The only thing I don't have right now is the radius. And if I'm given a point on the circle, I'm going to use my graph here to kind of represent what I'm trying to find here. If I'm given a point on the circle at negative 1, 1, and I'm given the center at negative 3, 1, 2, 3, positive 4, 1, 2, 3, 4. If this is a point on the circle, ultimately I want to find the distance, using the distance formula, I want to find the distance between the center and the edge of the circle, because that distance represents the radius of my circle. So I can use the distance formula. I could also kind of draw a right triangle and find the hypotenuse of that right triangle. Or also I said that every point along the circle, on the circle, represents the x and y at any point. So I could go ahead and plug in negative 1 for x and 1 for y, and I can go ahead and solve this for r squared. If you like the distance formula, you can use that as well. The distance formula is the square root of x1 minus x2 squared plus y1 minus y2 squared. And that's equal to the distance. So, no matter which way you try to do it, what you're going to end up with is using your distance formula or finding your right triangle. You're going to end up with a 2 squared plus a negative 3 squared, 4 plus 9, and r squared is equal to 13. I could find the radius, and that radius would be the square root of 13. But I'm not asked to find the square root. I'm not actually asked to find the radius. I need to find the radius squared. So the last thing I'm going to do is just go ahead and leave it as 13. And my final answer will be x plus 3 squared plus y minus 4 squared is equal to the radius squared, which is 13. So that's a quick video lesson on equations of circles. Make sure you review the video a couple times if need to, and also try the practice problems for extra practice.